might as well get this out of the way. I didn't get as much done as I wanted to today, but let's just go over what I did so I can not have to think about doing a video on it. So VP, why are there breakpoints here? That makes no sense. The breakpoints here make sense because this is the new stuff here. Viewport 2, initial viewport 2, yeah. So I have a viewport 2, and it's another it's another source viewport that's off screen, but it samples a subsection of the GLFrag chords, and it's meant to be a subsection of the viewport canvas, or the client area, basically. So when you move it around, you can... The usage for viewport 2 is to zoom in and out of shader code that is working with normalized screen coordinates. So we'll do some trickery with how we create those normalized coordinates so that when we adjust viewport 2, we can zoom in and out of shader code. So when I'm doing like a shader tutorial, I can use viewport 2 for that type of behavior. So it's basically a more conceptual viewport than viewport 1, because viewport 1 is going to be designed to be going over an actual data set in memory and using that data set as a in-memory tile map, whereas viewport 2 is meant to kind of like go over... It's more like a... I don't know, it's more pure math than... I don't know, it's just more abstract. There's something about it that's more abstract, maybe I'm just not able to verbalize. But its basic usage is to go zoom in and out of any shader code tutorial you might write. So if I write some shader code and I want to zoom in and out of it, I can use this viewport for that, right? And the shader code, none of those values actually exist in data anywhere, right? They're just rendered on the fly. So I'm kind of like zooming in and out of a data set that's rendered on the fly, and that's why viewport 2 is kind of more abstract. I've also added a initial setup for the viewport 2. Also, you notice that this has the prefix global variable, unlike these other ones that I probably need to refactor, the ones that are called lostvar. Now I'm pretty certain that I want them to be global variables, so I should refactor that eventually. Okay, let's go to the next breakpoint. I don't know if I put everything in breakpoints, but so in our shader, we have code for all the different viewports. So we have viewport canvas, viewport 0, viewport 1, and viewport 2. And these are just to get the locations of the coordinates of the pixels on the master memory, the pixels that store these viewport values. So these aren't the viewport values themselves. These are the locations on the master memory texture where those values are housed. Let's see what we got next. I missed a breakpoint back there. Oh boy. That doesn't look like anything new. Convenience methods. So this gets viewport 0 width as a float 32. This one gets viewport 0 height as a float 32. So we use this built-in getter. I don't know if I covered this getter already. The function names are this... No, I don't think I covered this, because this function name is exactly the name it has in the JavaScript code. This is a function within the adapter variables object, or adapter variables class, whatever you want to call it. And this, yeah, it has the exact same function name. So if I go Control F, I can probably find it. So here we are. And yeah, here we are in our JavaScript code. And the reason I keep all the function names the same is so that it's very easy to hunt down related chunks of code, right? Right, if you're consistent enough, the idea is to make the code so consistent that it's easy to understand, read, and it's easy to read and understand and walk through without needing any specialized tools, right? Just having a decent text editor should be enough to be able to wrap your mind around what's going on. Okay, so anyways, this getter, right, it calls this lookup function, and this lookup function is texture as uniform set number 1, and it's a getter that's going to get the value as a uint32, and it's going to fetch it from this pixel here. And if we go up to where that is, I've already been over this before, but texture as uniform set number 1, u32, right? It's going to take the index position of the pixel on the canvas, and once it gets that pixel, it's going to pack the RGB and A channels back into an unsigned integer to restore it to its original value before it got packed into the bitmap. Its original value, like way back when it was in the client-side JavaScript. Okay, so we got those convenience methods. Let's go down, because I know there's... well, let's not go down. Let's just go F2. Okay, the time variable is not new. I commented this out. So this is testbed shader, normalized coordinate or color. And what did I do? It looks like I've made some diagrams. So, right, we want the normalized coordinate to be 0.0 to 1.0 when the pixel is in the rectangle VP0. Does that make sense? Yes, that makes sense, because VP0 is the actual viewport, the actual screen viewport. So I'll show you what I have, because the shader looks a little bit different now. So if we go here, you can see that there's a gray border around this, and I'm not cropping off any of the image. We've just shrunk everything down so that it all fits within viewport 0. So the gray part you're seeing is viewport C, which is viewport canvas, or viewport context, whatever you want to call it. And that viewport always fits the entire OpenGL context. And the pattern you see is in viewport 0, which is our destination viewport. And if I hit another key, we can go... This will look kind of familiar. Right now, my... Ooh, it looks like I may have... Like, everything looks pretty good here, except for... It looks like my shader's in topsy-turvy land, because this pink value right here, I'm pretty sure it should be over here on this side. So it looks like somehow, rather than the Y getting flipped, the Y is okay, but the X somehow has been flipped. I'm fairly certain, because I'm fairly certain this should be... Yeah, I definitely know it's... Right, because the origin is supposed to be up here, and this is like a diagonal line that's growing from it. No, because I would have been like red, green, blue, CMY. So no, it's definitely flipped on the Y, because it would be red, green, blue, because I would progress how I would progress. I definitely would progress in that order. So I need to change that. I probably forgot to flip the coordinates back, but now you see this gray border around it, but it still fits everything, but now there's a nice gray border, and so we can resize the size of this viewport and still have the same contents just by resizing the viewport through our adapter variables object. So let's see. I'm gonna refresh for a second. Okay, Just wanted to make sure that this was still working and that I didn't like break anything. But yeah, that looks good. I do need to figure out why those coordinates, oh, well, there you go. So we have UPX, and then we have UPY right here. And UPY, we should invert that. Crap. So to invert that, we have to know it's the top value. And do we have that yet, or do we not have that? So if we scroll up here, we see VP0, but this is the entire canvas. So this would really be, so we can't. Well, how did we do it before? Did we not do it before? Well, oh, that's weird. Maybe I'm inverting it twice? Like, this should all be... Oh, no, because I'm grabbing GL frag chord here, and maybe I should be grabbing, like a variable that was made for me previously, like a F. Okay, oh, here's how I'm flipping it here in this shader. So I have a hard-coded 512, and I do not have... I do not have anything to flip this, because in order to flip this value, in order to flip this Y, I would need the canvas viewport size, which I don't have a getter for, so I need to make a note of that. So what I'll do is I'll just to do flip Y once you can get canvas VPC. Okay, so just making a note there that I want to flip the Y once I can get the viewport C width dynamically. Wait, that's a lie. Height. I want to be able to get the height in order. I need to know the height in order for me to flip this. Previously, I just flipped these kind of values by just hard coding in 512 there, but I'm trying to avoid that. But now that part's broken. So there's just some mapping logic here, and I don't really have a diagram. I'm working on a diagram right now. I'm working on some stuff to try to like explain what's going on here, but I'm not quite done with that. But this logic here, you know what maps one viewport to another, but I can't really remember which one. Oh wait, we have comments up here. Normalized within VP0. Okay, so VP0. Okay, so I believe it's just squashing the GL frag chord range so that it fits inside of VP0. So we don't want to crop off anything that was previously in the shader, which I kind of did at first when I was working on this. But we want this whole GL frag chord range. We want the whole thing to be squashed into viewport 0 right here, which is inset, right? So when we change the size of viewport 0, we're gonna like squash and stretch the image. We're going to squash and stretch the image. We're not going to crop the image. So I don't want this weird thing where if I move the viewport around on the screen, I don't want to like see different things as I move the viewport, as if like the viewport were like this hole into the screen. I know that's how you usually think of viewports, but like I don't want the viewport to behave like that. If I move the viewport somewhere, I want it to have the same data. Like I want the viewports to be like kind of like little CCTV monitors that you can place them where you want, and you always see the same thing, right? When you move a TV around, you don't see different things on the TV depending on where it is, right? So I don't want that behavior of the viewport being like a portal into whatever's like in the game world. That's not the way I'm doing this. that's my design decision, just because I think I get why people would do that when they're working with 3D, but for me, I don't know, it just seems very weird to do it that way. It just seems weird and unintuitive. Okay, so with that said, let's look at what we got here. So we got the normalized coordinates, percentage x. So the normalized coordinate x equals percentage x. Okay, that makes sense. Because normalized coordinates are just 0 to 1, so therefore they're percentages. So I get why that comment's there. I can't help but think that this was somehow better aligned with something and made more sense at one point in time. But yeah, let's just look at this. So Rx, I believe, is range x. Should probably make a note of that. Rx, range x. So Rx is range x, and so we have the GL frag chord minus now how could that be? The GL frag chord minus the now that this is definitely not range x. This is more like a point on range x. Do I have notes? Rx. Yeah, position on range x, and then we're gonna take that. I'm gonna be really lazy, and I'm just going to throw that in here somewhere. We don't really need to look up what ZER means. It means 0. That's not the confusing part. This was the confusing part because I just did not remember. So let's, I don't know how we're going to do this. Then we'll just, since this is JavaScript, I guess we'll just comment this out, but at least we have the origins of like where it came from for reference. So we're not like staring at it being like, what kind of mystery is that? Okay, so yeah, I think I was at lost for variable names or something, but so capital Rx is the actual range, and then Rx lowercase is the position on the range. So that's weird because this VP0 width minus 1, that would be the range, and why is it not in the comments? Because let's see this formula. Yeah, so I think I just did a really crappy job writing notes for this because the comments don't make sense. So this, yeah, right here, Rx equals, yeah, so this is definitely a range. Yeah, that's, so we could say, we can keep, right, so, I kind of get why I probably used the, why I used upper and lowercase, because now if I Rx and, wait, okay, width, yeah, and height RY, yeah. Because now when I, double click that, because they only differ in case, I can see all the related variables, so I kind of see why I did that. But without any notes about what those variables are, that's kind of confusing. Okay, yeah, so looking at this formula again, so we're getting a normalized coordinate, which is just a percentage along path, basically. And to get that, we're going to take, that's the current frag chord, and then we're going to minus by one of the origin points of the viewport rectangle, the on-screen viewport rectangle, and we're basically zeroing out this value. this means this value will go negative, but if it's negative, it's outside of the bounds, and it's like, it's part of that like gray border you were looking at. But basically, we want to get a, because the range of values is VP0. Oh yeah, that's the other thing. So this X, so XY, maybe I should just refactor this and use more variables. So this X and this Y, this is actually X0 and this is like X1. Yeah, and then, right, because there's a W and a Z down here. And this is Y0 and this is Y1. And so this is like the Y range. And this is the origin on the Y, right? So that we can have a value somewhere on the range. So this is range Y, right? We're calculating a value on the range, and then we're dividing by the entire range to figure out the percentage, right? And that percentage gives us a normalized coordinate. But that is really hard to read. So I might make a to-do here. To-do dot xyzw is very hard to read on rec vp0. Maybe unpack into. Now, like using a temp variable, like, okay, maybe that's less efficient, but I shouldn't really over-optimize. I should prioritize the code being clear. Hopefully GLSL can handle, you know, the optimization of redundant variables. I don't know if it can, but, you know, hopefully it can, because, yeah. Okay, so we do that math to get the normalized coordinates, and now we have unnormalized coordinates, because I realized, oh wait, I might want to get the frag chord back out of that. Now that we have coordinates that are mapped to the viewport rectangle correctly, well, they're normalized, but what if I want like frag chords that are mapped to that viewport rectangle? How do I do that? Well, that's easy. It's already normalized, so we're just going to take the normalized coordinate, and then all we got to do is multiply it by the range. So the range or so this is right here is the width of the on-screen viewport 0, and this is the height of the on-screen viewport 0. In the comment, you can see height -1 and width -1. Oh, I'm bad. Sorry, I'm bad. This is the height -1, right? So, right, because if we had a viewport that went from pixel 0 to pixel 1, right, that would be a 1 minus a 0, which leaves us with a 1. But since our logic is all inclusive, 0 to 1 includes the 0 and it includes the 1. Therefore, it would be 2 in length or height in that example. And so therefore, in order to get the actual height, we would have to plus 1, but we need the height -1, so the plus and minuses cancel out, and we're just left with this. And so I left a comment because I thought that was helpful, just to know what's going on there. But yeah, so there's no real good word for denormalized or unnormalized, so I just use the word maverick, like maverick. I don't know. I couldn't come up with a better word. But yeah, this is basically a denormalized coordinate, or an integer coordinate with floating point precision, whole number coordinate with floating point precision, yeah? A whole number floating point value, something like that. Let's keep going. So this is, so TBS is for testbed shader, and this is a uint color or coordinate, and so I was using this initially for the frag chords, but the idea is that maybe I want to warp the shader eventually around some interesting geometry, so I want to think of the coordinates as, well, they could be coordinates or they could be colors, and I want to intentionally make that vague when I'm thinking about it to help the creativity kind of work there and help my abstract thinking. So this is testbed shader underscore uint color or coordinate. So this is, are we inside the bounds? Are we inside the bounds of viewport 0? And so we'll look at these fragment coordinates, and if they meet all these criteria, right, being inside the left bound, inside the right bound, inside the top bound, and then inside from the bottom bound, if that's all satisfied, then we are inside. And down here, if we are not inside, we're just going to put gray. That's that gray boundary you saw. Like right here, that gray boundary is this logic right here. Okay, and otherwise, if we are inside of the viewport, then we go on to select our editor 1 shader code. So we have, right, different shader indexes. So this is the selected shader index that editor 1 has selected, and these are the different pieces of shader code that you can display in editor 1, which is our shader code gallery. Right, and we just invoke functions to inject the proper string into this case statement within the larger GLSL string. Going down, right, and then so this is testbed shaders outro, and you see the pixel fragment. We're going to set it to testbed shaders out, and if we go all the way up to the top, we should have a intro as well. We're setting up some common variables for yeah, so, oh god, this is ugly as, like, where did the other, okay, so there's where that, so this is also why I like to make my markers you know, characters, because sometimes you don't know what belongs to what, and I had thought that, oh, maybe this other one just got deleted somewhere. No, it's way down here. So because that is like way down there, we need to like and then snake case, we need to be a little bit more descriptive with our marker so that we know what's going on here. Okay, yeah. So, oh yeah, so that makes sense. So basically, all this code within editor mode 1. Yeah, editor mode 1 means that editor 1 is active, which is our gallery of shader code that we're testing out. So that would make sense that everything is the prelude before the main switch with all of the sub-shaders that we can render. Okay, so that makes sense. I was just confused. So maybe some extra indentation would be nice. But right now it's way too dirty to... It's not thought out well enough for me to be indenting and cleaning up yet. Okay, let's keep on going down. Namespace functions. I know this divider is new. Then adding stuff. Okay, let's see. I commented this out and then added this in here because we have those Maverick coordinates. So TVS Mac, PX, PY. Right? I just you know, kind of like right. It's kind of dirty because really I should just find where PX and PY is and just put TBS Mac in there. But like I just wanted to get it, swap out the parts and refactor it and get it unbroken as quickly as possible. So this is what enables the memory sampler. So if we go to key 0, the little memory sampler that shows us what's in memory, that code, this code right here is what is responsible for that. Yeah, yep, because that's why, right, we have this flipped, and we are no longer flipping that, because this coordinate is supposed to already be oriented correctly, but it's not, because we haven't fixed the TBS underscore NOM, the normalized version, that this coordinate is derived from. We haven't fixed that yet, because we got rid of our hard-coded 512 further up there. So I have to work on that. So this shader right here is old news, right? It looks all cleaned up because I thought I was done doing stuff with it, and now you can see it's all busted up here, right? So that's the nice thing about formatting things nicely, is you can see exactly, right? Like there's a little hint right here of some, you know, I've been messing around there, and I can see that indeed I have, because these functions I definitely remember adding since the last recording. And oh, I gotta stop